Now, this is the visualization I wanted you to have a look at. This shows you a traveling pulse at an interface. I've changed the pulse parameters to make a nice symmetrical shape. It looks a bit like a Gaussian. I've set alpha to 0.1, which is a nearly closed boundary. If we play that, you can see that this wave, so these are the individual waves, not the superposition. The incident waves gets inverted and travel straight back along your medium. Now, one question was what happens? Well, the shape is inverted. But another question was what happens at the boundary? So let's see if we can zoom in a bit on the boundary. Look at the blue dashed line. It's pretty much 0 at all points. If you had a completely closed boundary, it would always be 0. That's what a closed boundary is about. What does this mean for the pre-reading quiz? So the first one says, at which type of boundary is the reflected wave inverted compared to the incident wave and traveling in the opposite direction? So that's a closed boundary. You get an inverted reflected pulse. For which type of boundary is the total displacement, so the superposition, always 0 at the point of the boundary? That again is the closed boundary. Any questions on that? If you have no questions on that, I do have a question on that. I can take this out now. So here's a question. Remember, I said if we say f x minus ct is an incident wave, and it reflects off a boundary to create a reflecting wave, g, which travels in the opposite direction, so it's a function of x plus ct somehow. How are those two related mathematically for an open and closed boundary? So you've got to choose one for open and one for closed. And there's 3 options for each. Now, I'm starting to see a really interesting pattern here. So there's a really similar distribution for both of them. Now, one of them, the majority got it right, and the other one, the majority got it wrong. So for one, the 50-something is right, and for the other, the 50-something is wrong. So think about this for a few minutes. Now, if you think you really know the answer, can you explain this to your neighbor or someone in front of you or behind you? You have to be able to explain it. If you don't know, what are the questions to ask? Can you figure out what it should be? I'll re-deliver so you can re-vote as well. You may notice what's happened is that we've created more division in discussing it, which is really interesting. What it really means is that this is a really tricky point. This is a real area where we need to try and understand what it means, because this is where the learning happens. When you get all the answers right, it means you already got it. Well, you don't really need to do any learning anymore. And finally, this is our minus f minus x. So now we have that the fact that it travels to the left and it is inverted. So reflected and inverted. And this is our closed boundary. Now, mathematically, the derivation of this, I don't expect you to know, but I have written it out in some notes, so I will put that together with the slides when I upload them onto Blackboard.